Hi everyone, good morning. Welcome all. Welcome to this session. A very warm greetings from Mercy Technologies. So let's see what is our agenda for today. The agenda for today is we'll be seeing about the golden rules in coding. We'll be checking about a factorial program, a Fibonacci series program, and we'll be doing this time and space complexity analysis for the point number 2 and 3. For the first one, I'm not just speaking about this class or this course. It generally applies to all the programmers. So let's see what those golden rules are, and we need to follow all these rules, not just here, but any program or anything that we are trying to code, either it is on a piece of paper or in an IDE or in the notepad or whatever. So your program should be following these rules. Okay, let me tell you what those are. So points to be remembered while we start writing the code is by looking at the point number 1. By looking at the method signature, the interviewer should come to know or should come to a conclusion what you're trying to write just by seeing the method signature. What does method signature contain? It contains a return type, it contains the method name, and it contains the parameter type. So all these three should be proper, so that just by seeing that, interviewer or the person who is trying to review your code should come to know what you're trying to implement inside that method. What is the logic that you're going to write? And see, let's speak about the point number A, B, and C. The method names should be meaningful, the return type should be proper, and it should be having correct set of parameters in it, right? So a method signature contains a return type, that should be proper. It should be containing a method name, that should be proper as well, and it should be containing the right set of parameters. Let's go to the point number 2. Every method you write should have boundary conditions, right? Every method you write should have the boundary conditions correctly defined. So what are the boundary conditions? Boundary conditions are nothing but null conditions and empty conditions. So half of the exceptions that we get in real time is because we do not handle the end conditions properly. Like, let's say a parameter can be null, but you haven't handled its conditions, so that's why you get a null pointer exception. The parameter can be an empty string, or it can be something which is pointing out to something void which is empty, and you're trying to perform some operation on it, but you are not able to perform because it is an empty one. And at the end, we need to write clean code with proper indentation, even if you are writing it on a piece of paper. Like I told you, if you have a piece of paper with you right now, anything that you write, you just cross check, am I following all these 3 rules? There can be n number of rules, guys. There can be so many others, but these 3 are the most important one. These carry almost 75 to 80% of the weightage. All the others are a little bit different. That's fine. This applies to any programming language. This applies to any technology that you're using, right? Now let's try to write small piece of code. I mean, just a small class trying to follow all these conditions and see if we are able to perform it or not, right? Here I'm teaching this. The reason is it would become a foundation for our future codes that we are writing. If we know what exactly we need to follow, then for every code that you write from here, you'll follow the same thing. So what am I trying to implement over here today is I'll be taking an employee class and we'll be following those principles to see it's coming properly, right? I'm taking a class called employee, right? Just a second. Let me delete that if it already is existing. Okay. So I'm trying to create an employee class. So employee class has just 2 parameters in it, right? 2 properties for it. So what are those properties? Let's say it is employee ID, and I'm giving that as integer. Okay, and then so it has just two properties, guys, which is employee ID and employee name. So generally, when you try to write any object, when you are trying to create any object, so let's say in our case it is an employee. There are bozo classes which will be coming in real time. Let me just explain how do you do all those. So we have two parameters, I mean two properties for this employee class, employee ID and employee name. Okay, so let's create a constructor for that. So what am I doing? I am using this constructor using fields. So I'm able to create a constructor. With this constructor, I'm able to create some employee object. Let's say my employee ID is 1 and it is having a name as Surya. So I can create an employee object just by passing the ID and passing the name, right? I'm initializing the object here. So it's good to override the following methods every time you create a class like this, right? Source, what am I doing? I'm generating getters and setters for these two parameters. Okay, so after that, I always like everyone to follow one method which is generating the hash code in equals. Okay, let's not dig deep into all this, but I'm generating hash code in equals, and at the end I'm trying to override, which is the toString method. All these are default implementations given by Eclipse, so we need not struggle to
Sir,
implement this. The only code.
Surya sir, can you help us how to generate? Can you go little slow? How to generate equals or hash code? How to generate getters and setters and toString? Can
Okay,
you
so
please
let
tell
me come
again,
back
like
on.
all the things, like even constructor also from Eclipse point of view?
Okay,
Can you
yeah.
just restructure the code again? If you delete everything, that would be good. Step by step, how you are going, which menu you are going, how you are generating.
Okay, okay,
Thank you.
Kumar sir. I'll do it. Yeah.
I think we are unable to hear you.
Okay, yes, sorry, I was on mute, I think.
Okay.
Let me come back again. So we have only written two properties for our employee class. First one is employee ID, and the second one is the employee name, right? We have written only this much of code, but all the others we are trying to generate. So how do we try to generate? Let's try to generate a constructor. So how we should go? Source, generate constructor using fields. I'm checking these two fields and I'm generating it. So once this is done, what I want is, again, there is this source. I want to generate setters and getters for this. Getters and setters. I'm selecting all these two, all the fields. I'm generating it. Okay. So after this, I want to generate equals and hash code. Source, generate hash code and equals. I'm selecting these two. I'm generating it. After that, I want to generate toString as well. Source, toString, generate toString. I've generated. So this simple code of two lines, using the Eclipse shortcuts, we are able to generate this much code. So this is just for two fields, guys. Like in real time, we'll be having some fields, n number of fields, for example 20, 30 fields. You can understand how big the class could be. But here what I want, my main agenda here is not teaching what or how to generate all this. Yes, this is good to know, but the thing is I want to use or implement the coding practices that I told you previously. What is the coding practices? Just by looking at the method signature, the interviewer should come to a conclusion of what you're trying to write. So let's say I have a requirement now. My requirement is to change the employee name. So I need to write a method to change the employee name. Let's say I'm trying to write a class called employee test. Okay, so this is just for testing. My main intention is to write a method to change the employee name. What I'm doing, I'm just writing a method with name change emp name. Okay, with this method name, we are able to see, okay, in this method I'm trying to change something, right? I'm trying to change something. Okay, I'm trying to change something. What am I changing? I'm changing employee name. So with this, what should I do? I should pass the employee object inside this as a parameter. Okay, so this employee object should be changing with a particular name. In this case, what am I trying to do? I'm saying new name. Okay, so I'll be having an employee object. I'll be having a new name for that. Okay, so I'll be having a new name for that. So with this, I'm done with my method signature construction. But I told you it should be returning properly also. What will I return? I will return something of type employee, right? I'm returning something of type employee. Fine. So with this, we are able to see our method signature is proper. What is our method signature having? It is having a proper name. It is having two parameters which are required, and it is returning an employee. Just by seeing that, you did not write any logic here. Just by seeing this, an interviewer or the person who is analyzing your code, just by seeing this, what he'll say, okay, this guy is trying to change the employee name. Okay, he has taken an employee, he has taken a new name. Maybe he'll be writing some logic inside to change this employee name. So with this, he'll come to a conclusion. So you're half done with your coding, guys. With this, you're half done because your understanding is clear. Let's say even if you go wrong in your logic, that's fine, because he can a little bit correct you in the logic. But if you're going wrong in the first step itself, then your understanding itself is wrong. When your understanding is wrong, which means you will not be in a position to implement the logic. Fine. So this is the first point. Next, let's try to see what is the second point. The method name should be meaningful. That's fine. The return type should be proper and correct set of parameters to be taken. Yes, we have done the thing properly. Now, let me try to implement the logic here. What is the logic? Change name. So I'll be writing a method called So I'm writing a method called change employee name. So this method should contain the actual logic. What should it return? Okay, fine. I have already written the method signature. Method signature is done. Now let's try to implement the logic here. Okay, let's try to implement the logic. What is the logic? Logic is we need to change the name. So what am I doing? Return employee dot set employee name of, you are setting that as the new name. So you're setting the employee with the new name, right? Okay, instead of returning directly, I'll try to create an employee object. Employee. So I have created a employee object and I'm returning it. And I'm returning it, right? This is what the actual logic I meant. So Okay, so what am I trying to do here? I've created an employee object and I'm setting something in the employee object. Okay, equal to method is missing. Okay, so I've created a new employee object. I'm setting an employee object over here. Set the employee object over here. The setter should be returning a new employee. That's fine. So let's say, okay, so I'm creating a new employee. Let's say my new employee would be of type 1 and the employee name would be of, let's say, some but I think, okay, let's try to implement this as part of our main method, guys. Okay, so let me try to we will implement the logic, but first let's try to construct our client. So what am I doing? I'm written a main method. So inside this main method, let me make this static so that I can directly call this. So I'm making this a static. I can directly call this. What am I trying to do? I'm trying to call this method. And what is the employee object? So let me try to create an employee object here. One second. Let me try to create an employee object here. So what is this employee object saying? It is employee 1. So using my constructor that I generated previously, so I'm trying to create that. What is my employee ID? Employee ID is 1. And let's say the employee name is Surya. Okay, now I have a employee with this two properties. Now what am I trying to do? I'm taking this emp1, I'm passing this as a parameter, and the new name I want to change is, okay, I'm trying to change that to a new name which is called as Kumar, right? This is what I want to do. So after I call this name, I should be getting an employee object with the name called Kumar in it, right? So let me do this. Okay, so I have taken something called a changed employee, which is a variable again, and let me try to print this so that I can be double sure that it has actually changed the name. So what am I trying to do? I'm trying to print this. That's it, right? I'm trying to print this. So here, after I call this method change employee name, actually it should change something, and finally I will try to print the same. But inside this, let me try to implement the logic. What is the logic that we have taken? We have taken an employee object, and here we are passing a new name. In our case, it is Kumar. So what am I trying to do over here? I'm trying to, let's say, create, okay, I'm trying to change this one, employee dot set name of what? Of the new name, and what am I trying to do? I'm directly returning the employee, right? So with this, I have implemented the logic. I've implemented my main method. So with this, I'm implementing the logic, I'm implementing my main method. So let me try to run this. So what happens? Initially, my employee name would be having something called as Surya. And after that, when I call this method, finally it will be printing with the change name as Kumar. Let me try to run this one for you. So here you see, guys, we have taken a method and we are changing it. Now the employee ID is 1, but the employee name is Kumar. That's fine. We are following all the coding practices as per our point number 1, right? As per our point number 1, our method name is meaningful, our return type is proper, but the correct set of parameters that are taken, right? So here, now let's move to the second condition, the second point. Every method you write should have the boundary conditions clearly defined. Check for null conditions and check for empty conditions. So what happens? For example, let's say we have written the code and it's working fine, we tested it, but it's not proper, it's not good. If you write this code, then interviewer will not like this. If you write this, interviewer will not like this. I'm repeating that. The reason is you're not handling any boundary conditions. So what are the boundary conditions? There are two boundary conditions. One thing is you need to check for null, and the second thing is you need to check for empty. So let me try to say that. For example, let's say I'm trying to send something like this, employee1 as null. Okay, so I do not have any employee, but I'm trying to send it. So what happens now? I'm trying to run this code. When I run it, I get a null pointer exception, right? I'm getting a null pointer exception, which means the code that you have written is working, but it's not working in every case. But you should make sure the code that you're writing is working in every case. The same thing happens even when you try to solve problems in HackerRank, guys. So you need to have the base conditions properly defined. Only then you will be able to run the code properly. So let me try to implement the base condition one by one. Okay. So this is my actual logic, right? This is my actual logic. This single line is my actual logic. This single line is my actual logic. But let's say I'm trying to write the base condition one. So what is the base condition one? So base condition one says if employee is null, right? If employee is equal to null, what am I doing? Let's say I'm returning null, right? I'm returning null. That's it, nothing. Okay. So with this, what happens? Let's say we have a base condition now with the same. Let's try to run the program. So what happens? I'm having this condition. I'm not getting any exception. My program is running properly. My program is running properly. It's not having any runtime exceptions. It doesn't have a null pointer exception. See, it doesn't have an exception, but it is throwing something called as null. It is the problem of the person who is implementing. Here he can write one more logic. If it is null, then you do this, then you do that. That's fine, but it's not breaking the code, right? So just by having a base condition like this, it's not breaking the code. We have a base condition for something called employee1, right? So but there should be base condition for the other parameter as well. There should be a base condition for other parameter as well. What is the base condition? So what the base condition? Base condition 2. If new name is equal to null, let's say, what do? You try to return null. You try to return null, right? So this is one condition. Let's say if it is empty, base condition 3. Base condition 3. Okay. If just a second. Okay, let's try to implement the base condition 3. So what is the base condition? So what is the base condition? Checking if the new name is empty, right? New name string as a method is empty. If it is empty, then you do something. But if it is empty, then what you're trying to return an empty string. Here you can have any condition, but just for our learning purpose, here what I'm trying to do, here I'm trying to return, okay, I'm trying to return something. You need not change anything here, let's say. So when the name that you are given is empty, let's say you should not change anything in the employee class. So what I'm trying to do in this case, I'm not calling this method, but instead I'm directly returning from the line number 17, right? I'm directly returning from the line number 17. So let's try to see what happens in that case. So here I'm passing employee1. Let's say here I'm passing as null, right? Here I'm passing as null. Let me try to run this code. So what is this code saying now? Okay, when you try to return here, what it says, when new name, what is the new name coming here? New name, I'm passing it as null. So that is why it is coming to the base condition 2 and is returning null. But let's say we are passing an empty string. We are not passing null, we are passing an empty string, right? Let me run that again. So what it says, it's not altering your logic. The actual logic is not implemented, but it's returning from here itself, right? It's returning from here itself. So with this, what I want to say is, guys, for any method that you write, now this method, whatever is the condition, it will not give you a null pointer exception. It will not give you any other exceptions. Your code is clean. Your actual logic is this single line, only single line. But for this to work properly, you need to write all these lines. The same thing is in the employee class, your actual intention to write is this line number 5 and 6. But to make it properly, but to bring it to the industry standards, you're writing something from line number 7 to line number 54. So all these you need not write, but Eclipse writes it, right? So the thing that I want to press again now is the actual implementation that we are doing as part of our coding is very less. In our case, only a single line. But to make that work properly in every condition, you should make sure that you're following the coding practices. So let me just tell you once more. Every method that you write should have the boundary conditions clearly defined. So what are the boundary conditions in our case? In our case, the boundary conditions are checking for null and checking for empty, right? So by following first and second principle, we have written something. It's a very simple code, just single line of logic and just two parameters having a POJO class, right? And the third one, you should be writing clear code with proper indentation, even if you're writing that on a piece of paper. Let's say you go for an interview and the interviewer asks you to write something. You should write as if you're writing that in an Eclipse IDE like this. It should be having the correct spacing. It should be having, like, let's say the class starts from here, method starts from here, and finally this ends from here, and there is some gap. You're easily able to identify. You're trying to write the comments properly, everything, all these are just, guys. So this is not something which is so big. This is something intuitive. Only thing that you remember is, before you write something, make sure you are handling all the base conditions and the boundary conditions when you do this. And if you write your logic, because writing logic is very simple, I told you here, only a single line of code. And if you write your logic, which means you're 100% sure that it will work in any condition. So in that way, you can impress the person who is checking your code, right? You understood my points, guys? Please reply if you got what I try to understand. I try to teach now. Okay, that's fine. That's fine. Yes, you understood what I tried to do. So I'm telling you specifically about these rules, because from here, any code that we will be writing, we will be handling the method signature cases, we will be handling the boundary conditions, and we will be writing the clean code. If we make this as a habit, guys, if we make this as a habit, then that becomes very easy to code. As I told you, getting the logic and implementing the logic, it may not take that much time, but for you to write the clean code, it takes time. So that is the reason, from starting itself, I'm trying to make you to use to this kind of practices, so that it will be easier for you, right? So now let's go to what I'm trying to teach you today. So what I'm trying to teach, how to implement a factorial, right? So let me tell you what is a factorial. Factorial is nothing but, for example, let's say you have a number called 3. Okay, so for 3, what you'll be doing, let me open up the whiteboard for you so that it becomes easier. Okay, in this case, let's say, what is n factorial? N factorial is nothing but n into n minus 1 into n minus 2 into, it will be going until the part where it goes to a particular point, which is 1. So this is the least one, right? So in our case, 4 factorial will become 4 into 3 into 2 into 1, which is 24. 6 factorial will become 6 into 5 into 4 into 3 into 2 into 1, which is 720. So these are small examples that I have taken. So this is a factorial. This is how the factorial, this is how the problem statement would be looking. And these are the examples: 4 factorial or 6 factorial. 4 factorial's output is 24, 6 factorial's output is 720. Let me try to write that for you so that it becomes easier. Right? So what am I trying to do here? The thing that I'm trying to do is teach you what is a factorial. I'm not teaching the factorial. Instead, I'm trying to make you write the logic for factorial. So what is factorial? So factorial of 3 factorial, what you will be writing? So it is 3 into 3 minus 1 into 3 minus 2. So which means 3 into 2 into 1, which is 6, right? Again, 6, let's say it is 4 factorial. So what happens? 4 into 4 minus 1 into 4 minus 2 into 4 minus 3. So again, 4 3s are 12, 12 2s are 24, 24 into 1 is equal to 124. So this is how the factorial is, right? This is how the factorial is. But now our main intention for today is to write a program which makes sure that we are calculating a factorial, right? That we are calculating factorial properly. So for that, let's follow the same principles and try to write this code. Okay, so let me show the code for you directly that handles this factorial in iterative manner. So before going to this, guys, so let me emphasize two things. For anything here, if you see just by seeing the problem statement, we can understand. If you give an input something like 4, we'll be iterating from 4 till 1. So we'll be moving from 4 to 1, right? Let's say the input is 6, so we'll be moving from 6 to 1. So while we move, we write some logic over here, right? So for this we either use a for loop or use a while loop. When we use loops like this, the intention or the actual thing that we are trying to do is we are trying to follow a principle called iterative programming. So what am I trying to do? I'm trying to iterate over the number from 1 until the n and try to implement some logic. So using what? Either you can use a for loop or you can use a while loop. So using these two loops, you are trying to achieve something by iterating. So this is called as an iterative programming. There is one more flavor of programming to do this kind of activities, which is called as recursive programming. What is that? A recursive. So recursive programming, let's move into recursive programming tomorrow, but here I would like to concentrate only on iterative programming, try to find out the time and space complexity for the same program. So here I think you got the problem statement. Now let me jump into the code and show what actually has been written, right? What actually has been written. So here it is, factorial, which is iterative. Guys, as I told you, any method should have, as per our first principle, any method, by just seeing at that method signature, the interviewer should come to know what you are trying to implement as part of it. Here what I've taken a short method name, which is fact. You can give whatever name, but just by seeing fact, okay, we are trying to do something. Okay, what am I trying to take as part of its parameter? I'm taking a number called n and I'm returning a number called int. So what will it return? It will be returning the factorial of the number that we are passing, right? It will be returning the factorial of the number that we are passing. As part of a second rule, we should consider the base condition. This n is a primitive. It is an integer primitive. It will never be empty. It will never be null, but it can be a negative number. It can be a 0. It can be a 1, etc., etc., etc. In the example that I was showing you, so what is happening is n factorial is n into n minus 1 into n minus 2 into etc., etc., etc. Just by seeing this problem statement, we should be in a position to see if we can achieve something which is a base condition. So what am I trying to do? Which is a base condition, right? So let me try to derive some base conditions from here. What is the base condition? Base condition is always the factorial number n should be greater than or equal to 0, right? If you are trying to do a factorial for negative, even that may come, but let's say as per our requirement or as per client requirement, the number is greater than 0. This is the base condition 1. The second base condition is if number is equal to 0, then factorial is equal to 1. If number is equal to 1, then factorial is again 1, right? If n equal to 2, then that becomes 2 into 2 minus 1, which is 2. So until this point, guys, the first base condition is n should be greater than 0, and the second base condition is if n is equal to 0 or n is equal to 1, then the factorial is always 1. Let's try to implement the same here. So what we are trying to implement, the same.
Sir,
If n is
sorry
equal
to
to 0,
trouble you.
yeah,
I mean, your screen is not updated, I think.
okay, now you are able to see.
Yes.
Okay, guys, did you miss something? Did you miss something that I was about teaching?
Yeah, last 1 minute.
Okay, so what am I trying to say here is, let's try to derive the base conditions. So what are the base conditions as per our requirement? We need to find out the factorial. The factorial should be giving or taking an input which is n, and it has the following base conditions. So let's say n is greater than or equal to 0 always, so which means it can either be 0 or it can be something which is greater than 0, and it shouldn't be a negative number. So this is a requirement, that base condition that I am trying to implement, guys. If someone says no, you can implement this condition also, then it's up to you. But let's say, as to teach you what is a base condition, here I'm taking this is the base condition 1. And the second base condition is if n is equal to 0, the factorial is always 1. And the second thing is if n equal to 1, then the factorial is always 1, right? So these are the base conditions. From factorial, from n is equal to 2, what happens? 2 into 2 minus 1, which is 2, and n is equal to 3, which means 3 into 3 minus 1 into 3 minus 2, which is equal to 6, etc., etc., etc. This comes to our logic. But the first part, which is the base conditions, right? So let's try to implement this base conditions first. So what is the base condition? So here I've taken if n is equal to 0, then return 1, right? Here let me try to write one more base condition. What is that? If, right, if n less than 0, then what you are returning? You are returning 1. Return 1, right? Let's say this is one more base condition. So I'm taking this the first base condition, and the second is covering two base conditions which we are checking for either 0 or 1. And finally, this is our actual logic. So what is our actual logic? We have taken something called as a result, and the result is 1. We are initializing that to 1, and we are iterating over the for loop. And we are saying result is equal to result into 1. Okay, we are iterating over the for loop, and this is our actual logic. And finally, we are trying to print that result. Okay, here if you see, if we analyze this for loop, we are going from I is equal to n to I is equal to 2, because 0 and 1 are already defined, I is equal to 2, and we are decrementing this, and finally we are multiplying that result with this I, right? Let me try to run this. Here what am I doing? In our example, I told you, what is this? Factorial of 4 should be 24. Let's try to do this. Factorial of 4 should be 24, and I'm printing the same. Run as a Java application. So here it says, so we are getting 24 as our result, right? We are getting 24 as our result. Let's try to find out the factorial for 7. Factorial for 7, right? So what is the fact? One second. Let's try to do that for 6. run as Java application. Here, factorial for 6 is 720. That's what we are seeing, right? This is what we have seen. Factorial for 6 is 720. So this is a very simple program, guys. I have chosen this program as start because it gives you confidence that I can write base conditions properly, and the logic that I'm actually writing will be very small. The logic that I'm actually writing will be very small. So as part of our coding, as we move forward in data structures, so we'll be writing codes like this. The code should be handling the base conditions. The code should be handling our logic in a proper way, even though our input is wrong. If, let's say our input is 0 in our case, by using this case, we'll be saying it is returning 1. Even if it is less than, even if it is less than 0, then we'll be using this case. If it is 0 or 1, we'll be using this case. So this is how, and here we follow the iterative approach, and this is the for loop that we are doing. We are trying to return something, and we are trying to return the result, right? This is a simple code, guys. This is a very simple code. So what am I think you understood my logic as well. So as per our understanding from yesterday, or as per your listening for yesterday's class, I'd like you guys to tell me what is the time complexity for this. Try to calculate the number of steps and try to figure out the time complexity, and please return, or please reply me. Okay, fine. Let me pass 0 as well. Let me try to find out the base conditions, right? First. So I'm saying the base condition, I'm trying to returning, I'm passing a number called -1. What it's saying, it's 1, because as per our logic, it should be 1. So let's say I'm passing something called as 0. Even the 0 factorial should be coming as 1, right? 0 factorial should be coming as 1, right? This is as per our base condition. Let's say you do not define these base conditions properly, then you'll be ending up in messing up your logic, and the output will be wrong, right? And the output will be wrong. So with this, guys, I just want you to give me the time complexity for this program. What is the time complexity for this program? Okay, good. The time complexity for this will become order of n. The reason why it is becoming order of n, is my voice audible, guys? Am I audible? And is my screen proper? Okay, fine. So here what I want to say is, we have taken a for loop, and it is running from I is equal to 2 until n. For example, let's say our input is what? Our input is 6. So we are starting from 6. We are starting from 2, and we are coming until 6. So here, as per our program, so what we try to do is, so what would be the number of steps? I told you how to calculate the time complexity, right? For example, in our loop, and the input is equal to 6. So if input is equal to 6, in our for loop, we are doing from 2 to n, right? So 2 to n, in the sense 2 to 6, which means 4 steps, right? 4 steps. Let's say the input is 200. So we'll be doing for loop from 2 to 200. So total number of steps would be 198. So let's say the same example, if you take, you'll do the same thing. So our time complexity will be something like n minus 2. But I told you we need to ignore the constants, because let's say even if our input is 1 crore, so our number of steps would become 1 crore. So we do not need to consider about those 2 steps. So that is why the time complexity will become big O of n, order of n. I have given you one example, right? Like you and your friend, like you go for buying a pair of shoes, and finally your friend, and you have bought socks as well. Your friend is asking, what did you buy? You say that you bought shoes and not socks, because socks is like very less in comparison to shoe. Similarly, our input is, let's say, 50. So number of steps are coming to be 48, right? 2 less than 2 is very less in compared to 50, and that becomes, even if your input is 1 crore, your number of steps would become 2 less than 1 crore. So 2 is, and it's not that significant, so we can ignore this 2 and finally conclude our time complexity to be order of 1, right? You understood the time complexity part, guys? You understood till now? Like, we have written some logic, we followed the base conditions, we properly did the indentation, we followed the practices, we have found out the time complexity for this simple code. All right, for this simple code. Okay, good. Now let's go to the second part and the last part of today's session. What is that? Let's go a little bit more complex. Let's try to find out, let's try to code for Fibonacci series. What is Fibonacci series? Okay, what is Fibonacci series? Fibonacci series is nothing but, by seeing this example, I'll tell you. So what is Fibonacci series? Fibonacci series starts from 0, then it is followed by 1, and then it is followed by 1 again it is 2. So how it is done? The first, here we got 0 plus 1 is equal to 1. This is what it says. So that is why there is 1. And now 1 plus 1 is equal to 2. 1 plus 1 is equal to 2. That's what it is there. And then 1 plus 2 is equal to 3. 2 plus 3 is equal to 5. 3 plus 5 is equal to 8, 5 plus 8 is equal to 13, and so on and so forth. So the previous 2 numbers you have to sum, and you need to print next to those 2 numbers. So in this case, we can finally conclude, we can easily conclude one thing. What is that easily to be concluded one? There is a base condition. The bases are 0 and 1. So these should be printed irrespective, like whatever is the number that you give, the 0 and 1 should be printed. And from here, the next number would be 0 plus 1, which is equal to 0 plus 1. And after 1 plus 1, here the value would be 2. The reason is you are calculating 1 plus 1 here, 1 plus 1 here, 1 plus 1 here, and here what you're doing, 2 plus, like 1 plus 2. So in that way you're trying to find out the Fibonacci series, right? This is what a Fibonacci series is. So if you see, what is the Fibonacci series? After 5 plus 8 is becoming 13, 13, and 8 plus 13 is becoming 21, and this is how it goes based on the input that we give. For example, let's say you try to find out the Fibonacci series of 100, so you'll be doing the same operation, you'll be going until that 100, and will be printing the series of numbers, right? This is our requirement. Our logic, we need to think about the logic now. So how do we think about logic? The one thing that we are clear is, there is something, let's say you are giving some input as 1 or 2 or 3, whatever. So you should be iterating from a number called 1 until the number called n. So you should be doing some multiple operations, so that for that you'll be taking 2, which is either for, or I told you one more is while. Okay, so this is one is for and the other is while. So we have implemented previously using a for loop. Now also let's try to use a while loop and try to implement the same logic, right? Implement the same thing. So here, let me erase everything. Okay, here Fibonacci series, I will explain the program to you now. What is a Fibonacci series? Using an iterative approach. I told you our logic should contain the proper naming condition. Here I have just given a small name. You can give the number as big as possible, but even though if your method name is concluding, okay, this is what I'm going to do as part of my coding, then it's fine. So, and the input is n and the return type is int, right? This is the method signature, and the method signature is following the principal number 1. So what is the thing next is, what is the thing next is here. I will give this program to you guys as part of, I'll give you the notes, or maybe you start implementing. What I want you guys to do is start writing the base conditions, right? Start writing the base conditions. Here I have already written the base conditions in case if it is less than 0 or whatever. You, as part of your practice, you try to see what happens when you give a negative number, etc., etc. Here our base condition, as I told you previously, is when the input is either 0 or 1, the first two numbers to be printed is 0 and 1. This is a base condition, irrespective. So what are those two numbers? First two numbers, I'm taking two variables called a and b. I'm taking two variables called a and b. So what is that? And there is one more variable which is c. This will be useful for my logic. Okay, first two numbers a and b I'm printing straight away I'm printing. So what am I printing? 0 and 1. Here if you see, 0 and 1 are printed. From next time onwards, so we should do 0 plus 1 is equal to 1, 1 plus 1 is equal to 2. That is what we need to do. So from next time onwards, what we should do, we should print the next number as the sum of a and b, right? So what am I trying to do? I'm iterating from I is equal to 2 until n, and I have already printed a and b. Now the next step as part of my loop is I need to print c for that. Okay, I need to print c. So I need to print c, but what is c? C is nothing but a plus b, right? This is what it is. C is here, a is equal to 0, b is equal to 1. C is nothing but a plus b, right? C is nothing but a plus b, and you're printing c, right? And as part of your second iteration, when the control comes again, so you should be changing your a and b values, right? Why you should change a and b values? Because they need to be updated to bring the newest c value. I'll explain this to you at the same. So this is what it is, right? So here currently my a is 0, b is 1, and now my c would be 1, which is 0 plus 1. So we'll be moving one step forward. When you move one step forward, you need to move a and b as well. So that is why what you're doing as part of your code, you're moving a and b as well. What you're saying, a is equal to b and b is equal to c, and again you are updating c to be a plus b. So if you give something like this, your logic is nothing but you are incrementing c, and this a and b you are using them as some variables called temporary variables, right? Right? Okay, okay, good. Okay, fine. Now this is what the implementation for Fibonacci series is, guys. So let me try to run this program for you. What am I given? I'm given Fibonacci series of 8. Let me try to run this program and show what it actually gives me. So what it actually gives me, it's starting from 0 until the number called 21. The same thing that we have seen in this. Starts from 0 until the number called 21. Your input is something that you have given. Based on that input, you should move forward. For example, let's say I give my input to be, let's say, 10, right? It should move two numbers ahead and it should be printing it, right? This is what it is. So this is what it is, right? 34 and 55. These are the two numbers which are coming. You give the as much number as possible and try to find out, or try to figure it out, or try to make sure that you are able to understand the program and run it. So our base conditions are already defined, guys, but here you have a base condition, like if the n is less than 0, then you return something. You can do that. You can write a base condition while practice with the base conditions, right? So this is the iterative approach. Let me try to debug and explain you so that it becomes double easy for you, right? Let me try to debug this. So as part of my first iteration, what am I trying to do? Here, a is equal to 0, b is equal to 1, and c is equal to 1. This is our initialization process, right? This is our initialization process, and irrespective of whatever we do, we are printing 0 and 1. So our base condition is what? 0 and 1. Yeah, we printed that. Now let's go into the loop. What am I trying to do? I'm moving a and b values. So what are a and b values now? A value will become 1, b value will become 1, c value will become a plus b, which is c, right? I'm printing c. Yes, I got 2. Now let's move to the next one. So with our next, what you try to see here is the a and b's values are updating, and c is the sum of updated a and b value. You're trying to print c value, right? 3. So here 5, right? Same thing. You can see how these numbers are changing on my right side. So this is a debug perspective, guys. It's good to learn this. Okay, 21. And finally, here if you see the A and B values are changing, my C value is changing, and I'm done. Now what am I done? I'm done, right? I'm done. Here it is. So here I'm not catching the return type or return value or whatever. So what it says, the return type, the Fibonacci series of 10 will be returning the final value of 55. But here for our example or our understanding purpose, I'm printing every number in the iteration. So this is an iterative approach to solve the Fibonacci series program. Did you understand the logic, guys? Please say, are you able to follow the logic? Okay, how to debug, right? How to debug. Debugging, learning to debug in this logical kind of a programming will actually make you a master in debugging, right? Because we will see how these values are changing. Is your logic working properly or not? So nothing but when you open Eclipse, you write some code, right? You want to see in this loop at one particular point, where is my debug point coming, etc., etc. So what I do, let's say I put a debugger at point number 9, right? Just by seeing the code, what I see is, okay, if I have a debugger point at 9, I will actually see if I'm able to print this A and B or not. Okay, so with this intuition or with this understanding, what I did, I've taken something called here next to 9. In this line, I'm just clicking 2 times, my left pointer of mouse, clicking 2 times. I clicked for 2 times and there is a debug point here. So as there is a debug point, I'm doing right click, debug as Java application. So when you try to debug as Java application while the program is running, it will stop at a particular point. What is that particular point? That particular point is at the point where you have put the debug point. So your program has executed until line number 8. Okay, your program has executed until line number 8, but the program has stopped at line number 9 because you put a debug point here and it is waiting for your instructions. Okay, it is waiting for your instructions. What you want to do now, you want to see what will be printed as part of C. So for that you need to move forward, right? Here there is an option. If you see here there is an option called F6. F6, what it says, go to next line. F6, you either press this one, or you press F6. Let me press this one right now for you. So it came to the next line, came to the next line, came to the next line. So calculation for C is possible. Now we are printing C, right? So again, when you say, it will not go to next line, because next line, as part of our instruction or as part of our logic, next line should come again back to 9, because this is a for loop. It will move like this for until this condition, until the n would be reached, right? So again, what you did, so here it is again, you're going F6, 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 F6. So like this, if we see our right side, the values of A and B are changing, I is changing, at the same time we are printing. So in this way we can actually see what is happening inside code, right? This is how you debug it. And finally, after it reaches our end condition, it will be coming out of this for loop, right? It is coming out of for loop because now the number is n, right? So it came out our for loop and it is trying to return C, but even though we return C, we are not catching that in any way, so our execution is done. So at any point of time you want to end the execution, there is one more point, which is you can press F8. In that case, F8 will terminate your program. That's it. This is debugging, guys. This is how we can debug the code. So I advise you, take this code. It's very simple. Try to build your logic, try to see how it works, and try to write it on a piece of paper. Then you try to write it on your IDE, etc. Because in interviews, people generally in your first round or second round, they ask you to write it on a piece of paper. So you should write it, and you should be in a position to say yes, it is handling all the base conditions, etc., right? You got what I tried to teach you today, the Fibonacci series. Are you able to follow me? Are you able to follow me? Are you able to follow the logic? So for the people who are attending from outside, so this is our WhatsApp number. You can ping us. It's not function of 8, it is a key called F8. So at the topmost row, escape is there, right? At that F1, F2, F3, F4, there is something like that. So you can directly click F8. This is our WhatsApp number. So as part of our final conclusion point today, I want you guys to give me the time complexity of this code. What is the time complexity of the method that we implemented? What is the time complexity of the method that we implemented? I'm waiting for your replies. Okay, I see people. Okay, yeah, Danny, you have asked a question while debugging. See, that is called as a Eclipse perspective. So I'll tell you Eclipse perspective. There are different perspectives in Eclipse, right? Let me tell you what are Eclipse perspectives. So if you are able to see my screen, I understood the concept of time complexity perfectly. Awesome, great. Yes, so if you see your Eclipse on your top right corner, on your top right corner, there is a point called debug, right? There is a point called debug. So at the same time, next to that is called as a perspective, right? Next to that, there is something called perspective. Here what it says, there is a perspective called debug, and if you open the perspective called debug, and if you minimize all this, so you will be getting that perspective. For example, let's say you want to have console over here, right? You want to have console over here. This is the perspective that I have defined, guys. I have I have taken a console over here. So what happens, let's say I want breakpoints to be coming here, right? What I did, I'm putting the breakpoints over here. I'm dragging that and I'm putting that here, right? Let's say I want to have variables, or let's say I want to have expressions. I'm taking that, I'm dragging that, and I'm putting that here. Now let's say you have something like this. Fine, you have something like this and you want to save this for your futuristic purposes. So what you do here, you open perspective, right? Here you open perspective, and here you open perspective, and here if you see, okay, just a second. Here if you see, we can have something like that. We can have different perspectives over here. Let's say you have recently joined your company and you want to learn something on the code, and if you want to see like what kind of methods are there. So what you have, let's say you go for a Java type hierarchy perspective. Let's say I try to open the Java type hierarchy perspective. So here in the type hierarchy perspective, so what it says something like this. And again, there is a project perspective, there is a package perspective. So it's like, it's a way of just seeing, uh, how you view your code. That's it. You can just search, you can try to explore it. It will be very easy for you to understand, right? Yeah, people have understood the concept of time complexity. Iteration learns, okay, straightforward. Fine, it runs for n times, and that's it. The time complexity is order of n. So if your input is 100, it runs for 100 times, so that the time complexity will become order of n, right? Simple. The time complexity will become order of n. I think you guys have understood, guys. This Fibonacci series and Factorial series programs uh, are something which is simple, but but you need to practice that. You try to debug that and see, get hands-on on it, and from with this base we can move forward to a little bit bigger level, to the next level, right? So I'm done with today's explanation, today's topic. I'm done with today's agenda. Okay.
Okay, thank you, Surya sir, for your detailed explanation. We know that in interviews they will ask like write Fibonacci and all these programs like Factorial and all. But usually people they used to mug it up, or they will simply only consider about logic. They will not follow base conditions and all. But you clearly explained to us. Thanks for that. So guys, some important things. So you can go through the recordings if you have doubts. You may not understand at one shot, but you can go through the recording. It's not like easy subject. There are many concepts are there. So practice it. Programs we will share it later. In case if you forget, you can just remind us. And second thing is like we are as per our promise, we said we will give 3 or 4 classes free. So today is the 4th class. So we are planning to close the door. People who are attending regularly or whoever joined today or yesterday, you guys, this is a 2-month course. So, around 50 hours Surya sir needs to teach. And, we are taking much effort on this. So we are charging some reasonable fee. So comparatively outside it's very less. Outside they charge around 15 to 20,000. If you want, you can check outside, but we are charging very